Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's session we are going to study one of the most important topics, and that is compounding of plastics. Now plastics has many properties. It will not get reacted with oxygen, it will not react with water, it is corrosion resistant, it is non-biodegradable, and that is the reason why it is very strong and can be useful for almost everything. But how does all that happen? Plastic itself during manufacturing does not have all these properties. All these properties are added to the plastic by adding little ingredients inside it. That means addition of something to the plastic is known as compounding of plastic. In today's session, we'll see what exactly is compounding of plastic and what are the different things which are added to the plastic in this process. Compounding of plastic. Compounding itself means adding something. Now when I take plastic, of course plastic is not something which we get from nature. Plastic is synthesized. It is man-made. That means plastics are made by us. We take different chemicals, we mix those chemicals and we make a plastic. Now this plastic, when we make them, they are not perfectly okay. They do not have all the physical and the chemical properties which we need. Now, what do we mean by physical properties of plastic? Physical properties of plastics are its heating point, its melting point, boiling point, where it reacts, where it does not react. Again, the wear and tear and the brittleness of the plastic comes in the physical property. What do I mean by chemical properties of a plastic? It getting oxidized, it reacting with chlorine, it reacting with sulfur, reacting with different atmospheric gases, or reacting or dissolving in water. All of these properties come under the chemical properties of plastic. We'll see both of these properties over here. Plastics are manufactured synthetically. Synthetically means they are man-made. They are not got from nature, but we make them using different chemicals. Using raw materials, mostly from natural gas and petroleum. So whenever we have natural gas and petroleum, both the raw materials are used to make plastics. Or from coal, mines, forests, farms, papers and textile mills. So again, the waste products of all these mills can also be used for creating plastic. In addition to the raw materials chosen, the plastics are generally compounded with some other substances. Now what do we mean by compounding? Compounding means addition of materials. In short, addition of properties. If I want my plastic to be of a certain type, I will add that certain material into the plastic and I'll make sure that that property is inculcated into my plastic with the help of addition of that material inside the plastic with some other substances, so as to impart certain specific properties to the product. Usually such molding compositions are prepared from two or more of the following material groups which are given. So over here we are talking about molding compositions, and the composition is one of the most important term used in plastics. Composition is nothing but the amount of substances which are being used. If I want a plastic to act as a lubricant, I will add certain lubricating agents inside it. So if I am adding certain lubricating agents inside it, I will make sure that I am adding them in proper proportion. If I add them very less, my plastic will not act as a lubricant at all. If I add them very high, the other properties of the plastic will get damaged and that plastic will turn into nothing but a normal lubricant. And that is the reason why we have to make sure that the original properties of the plastic remain the same, plus certain new properties are being added to it, making it a better material for use. Let us see all the different things which can be added to the plastic. So over here, the first thing we have are the binders, the second are fillers, the third are pigments, fourth are catalysts or accelerators, fifth are plasticizers, sixth are lubricants, and seventh are stabilizers. So now we'll see all of these in detail, but let us just know what these are. The first ones are the binders. Binders are nothing but used for binding the resins. For example, if I have a plastic sheet over here which is not completely made and there are carbon atoms in it, if I add binders inside this, these binders will help in binding these atoms more strongly. And since these atoms are bonded more strongly, they will now not react to any chemicals or any kind of gases which are present in the atmosphere because of the binders which are binding them very strongly. The next are fillers. Now fillers are something which is added to the plastic or to the polymer to increase the productivity of the polymer. Now what do we mean by productivity? Increase in productivity means increase in utilization or utility. That means if I add certain metal oxides to my plastic, then with the help of that metal oxide, that particular plastic can also help in conducting electricity. A plastic conducting electricity is very rare, but if it starts doing that, that will be very useful. With the help of fillers, we can try changing certain of its physical and chemical properties. The third are pigments or dyes or coloring agents. Whenever we look at plastic generally comes in all colors possible. There is no single color which will not merge with plastic, and thus we add certain pigments or dyes inside the plastic resin to make sure that it looks more attractive in vivid colors. The fourth one is catalysts or accelerators. The catalyst or accelerators are present in the plastics or are compounded in the plastics to enhance the physical and the chemical properties of the plastics. Next are plasticizers. Plasticizers are the substances which will give the plasticity property to the plastic. We will see the plasticity property of plastics in detail when we discuss plasticizers. Point number 6 is lubricants. Lubricants are those substances which have lubricating properties. So if I have a lubricant which has a lubricating property and I add it to plastic, that plastic will also start acting or behaving like a lubricant. And that is the reason why plastics under certain chemical reaction are also known as lubricants and behave such. Finally, we have stabilizers. Stabilizers will help plastic to stabilize if they are going to certain chemical reactions. So if I have a plastic bag and I try to heat it, it will get burned down, but it will not explode because of the stability which is there in the material obtained by the stabilizers. Let's first discuss binders. The term binders means to bind together. That means it will take the molecules of the plastic and it will bind them together. Now, if I'm using a binder in the plastic, all the atoms or the molecules present in that particular plastic will be binded together strongly. And that is the reason why to break down this plastic will be difficult. If I have a plastic container and if I'm adding hot food inside it, that plastic will not immediately melt inside the food. Why? Because the binders are present in the plastic, and those binders make sure that these plastic molecules or atoms, those macromolecules, are binded together strongly. Binders hold other constituents together during the manufacture. Usually natural or synthetic resins or cellulose derivatives. Now, why do we know as cellulose derivatives? Because certain plastics are also made up of waste of textile mills, paper mills, and parts of forests. And that is the reason why there will be some cellulose content in it as well. Are used as binders, which are high molecular weight substances. Binders influence the properties of plastics. They influence the properties very strongly. The type of the treatment during molding operations also depends upon the binders. That means if I have a good amount of binders present in my plastic, I can melt the plastic for a little longer time, get it into completely liquid form, and then mold it into intricate shapes and particles. But if the binders are less, the quantity of binders in my polymer is less, then the atoms will not be molded, and if we start heating it after a certain point of time, instead of liquefying, it will get converted into some other gelatinous mass. That means the atoms have broken down and the entire system, that means the entire composition, has disrupted. If binders used has comparatively low molecular weight, then plastic gets molded easily and vice versa. So if I have a binder with a very high molecular weight, now when I'm talking about high molecular weight, that means I will have many molecules present in the binder, and these molecules will be in complex forms and bonds. So if I'm adding this complex forms and bonds molecules inside the plastic, what exactly happens is these forms and bonds will not get easily melted. And if they will not get easily melted, it will be difficult to make plastic pour into the molds which are intricate or delicate in shape. But instead of that, if I have binders which are not very high in molecular weight, then they will melt easily because there will be no complex bonds between them. And since they start melting easily, with easy melting of it, the plastic will also in turn melt easily. And that is the reason why we can just pour this plastic into delicate molds and we can unmold it very easily as well. The second thing we are talking about are the fillers. So we have fillers, also known as extenders. Fillers and extenders are certain substances which we add inside the plastic and it will change the properties of the plastic. An example I gave before was conductance of electricity. If I'm adding certain kind of fillers inside the plastic, it will make the electrons present in the valence shell of the plastic jump up to the conductance band, and because of the conductance band, these electrons will flow from one point to another, and flowing of electrons is nothing but current electricity. That plastic will start conducting electricity. But apart from that, there are many other physical and chemical properties which fillers or extenders can give. Let us see a few of them. Fillers or extenders impart better tensile strength. What do we mean by tensile strength? If I have a plastic rod and to this plastic rod I am attaching certain weight, and because of that weight this plastic rod is getting extended. So if this plastic rod is getting extended, that means the properties of this plastic rod are getting changed. Firstly, this plastic rod was thicker, but as soon as I added certain weight at the bottom and it started getting extended, the diameter decreases and it becomes thinner and thinner. When I release that weight from it, this plastic rod tries to get back or gain back its original shape or size. The tensile strength of plastic is that strength of resisting a lot of pressure and a lot of load without breaking down. And this tensile strength can be improved with the help of fillers or extenders. Fillers or extenders also contribute to the hardness of the plastic. So there are two kinds of plastic. Let's take an example of a polythene bag. Now polythene bags are soft plastics. So PVC pipes are hard plastics. So if I want to convert this polythene bag soft plastic into PVC pipe hard plastic, I'll have to add in certain materials. And these materials are nothing but fillers or extenders which will give hardness to the plastic. The third is finish. If I have a plastic which does not have a very good finishing, I can add in some fillers or extenders and make sure that that plastic has a really glossy or a complete finish to it. The fourth point over here is workability. That means how much work can a plastic do, for how much time does a plastic remain once it is starting being utilized. And the workability can be improved to high levels with the addition of fillers and extenders. Point number 5 is opacity. Opacity is how opaque do you want the plastic to be. Again, this is a desired property. If I want the plastic to be opaque, I will be adding certain fillers inside it and make the plastic opaque, etc. to the plastic material. The percentage of filler varies for the type of plastic. The highest percentage can be up to 50%. Now the highest percentage of addition of filler can be only up to 50%. The other 50% has to be my normal plastic. Now that is because if I add more fillers to the plastic than the original composition of the plastic, then the plastic will not retain its original properties and it will start behaving like only the filler. And that is the reason why the highest percentage or the amount of fillers I can get into or put into plastic is only up to 50%. The fillers which are added only to improve the mechanical strength of the plastic are known as reinforcing fillers. So if I know that my plastic is heat resistant, is corrosion resistant and everything is fine, but I need to improve the mechanical properties of the plastic. So only to improve those mechanical properties of the plastic, I will add certain fillers, and these fillers are known as reinforcing fillers. They reduce shrinkage and brittleness. Now what exactly is brittleness? Brittleness is breakage of plastic once it forms from a certain position. For example, glass is brittle. Why? Because if I drop a glass from here and it goes down, it will eventually break. Thus, reinforcing fillers will be the ones which will reduce the shrinkage as well as brittleness of the plastic. The fillers may be organic or inorganic. Organic fillers are those fillers which contain carbon and hydrogen. That means hydrocarbons as the main atoms or the elements inside the entire filler. Inorganic fillers are those fillers which do not contain carbon or hydrogen as main atoms or elements. inorganic fillers are those fillers which do not contain carbon or hydrogen as their main atoms or elements. Over here we have few examples firstly of organic fillers. Now over here in organic fillers we know that hydrocarbons are main. Apart from hydrocarbons, generally all natural fillers are considered to be organic fillers. So over here we have wood floor. Wood floor is nothing but we take wood and then we pulverize the wood. That means we powder the wood into very small particles, and this is known as wood floor. The second is cotton pulp. The third is paper pulp. Fourth is carbon black. Then we have graphite, and we have powdered rubber. So all of these contain hydrocarbons in it. Of course, carbon black will contain a carbon in it because the name says, but even cotton, paper, graphite is made up of carbon. So if you want to know the structure of graphite is nothing but hexagonal shape. There are layers of it, and these layers are connected by van der Waals forces. So this what I'm drawing over here are the van der Waals forces, and below it again there will be a layer of it, and each and every vertex over here is carbon. So graphite is nothing but only carbon. Again, powdered rubber, if you see rubber, the natural rubber, the spiral form of rubber, it's something like that. But again over here there is C and then a double bond. That means even this is organic, it contains carbon and carbon. Wood, of course we all know wood is made up of carbon. Cotton pulp, paper pulp are made up of carbons. Carbon black contains carbon. Graphite, as I just showed you, contains only carbon, and powdered rubber also contains carbon. Thus all these are the examples of organic fillers. For inorganic fillers we have asbestos, we have powdered mica, we have silicate clays, we have talc, we have zinc, lead oxides, etc. So zinc oxide is nothing but ZnO, lead oxide is nothing but PbO. Now if you look carefully over here, nothing has carbon inside it, and nothing of this is formed in the natural form. That means we do not get it directly from the nature, from the forests or anything like that. Of course these are elements which we get from nature, but we have to extract them and refine them and then get the oxide forms of it. These are all the inorganic fillers. Point number 3 are pigments, dyes and coloring matter. All of these are used to color the plastic and to give certain kind of color and look to the plastics. These impart desired color to the plastics. The next we have over here is organic dye stuff and inorganic pigments. Now organic and inorganic, again organics are the substances which contain carbon and hydrogen in it. Inorganic are those substances which do not contain carbon and hydrogen in it. There are two types of dyes, organic dye and inorganic dye. Organic dye will contain hydrocarbons, inorganic will not contain hydrocarbons. The natural dyes that we get are all organic dyes, are used for a purpose in small proportion. Dyes are always used in small proportion. Even 1 drop or 2 drop of dyes can be used for coloring an entire batch of plastic, and that is the reason why we do not have percentages over here. Organic dyes or inorganic dyes, both of them are always used in small proportions. Point number 4, catalysts or accelerators. These are used to increase the rate of polymerization of fusible resin binder to form cross-linked infusible formed during molding operations. What does this entire statement mean? If I am making a plastic, so now this plastic is made up of carbons. So I'll just draw different carbons, and these carbons are in linear chains. This is nothing but my resin. To this resin, I'm adding certain kind of binder. Now this binder will help in binding the molecules of the resin. Now these catalysts or accelerators will help this binder to bind the resin very quickly. So if I am adding certain kinds of binders, if you can see, these square boxes are nothing but my binders. This will start binding these carbons vertically as well, and they will form a cross link over here which is infusible during the molding operations. Generally, thermosetting plastics involve use of catalysts. Now thermosetting plastics are plastics which have many cross linkages, and that is the reason why after heating them once, if you start to reheat them or you try to reheat them and remold them, that is not possible. That is the reason why thermosetting plastics are non-biodegradable plastics. Why are these non-biodegradable plastics? Because there are many cross linkages between them which cannot be broken. And why do we have those cross linkages? Because of the amount of binder which is present in it. And this binder binds very easily in presence of accelerators or catalysts. Use catalyst normally on an acidic or basic catalyst depending upon the type of the thermoset. The catalysts are added in small quantities. Again, the catalysts which we need are in extremely small quantities. We do not need large quantities of catalysts because these catalysts, even in small quantities, will help the binders to bind into the plastic very easily. Commonly used catalysts are hydrogen peroxide. Whenever I'm talking about a peroxide, I'm talking about any element twice and oxygen twice. So that will be H2O2. H2O2 is nothing but hydrogen peroxide. The next, I'll draw benzoyl peroxide over here. So whenever I'm talking about benzoyl peroxide, there are two benzene rings. This is one benzene ring. This is another benzene ring. Then over here, I have oxygen-oxygen linkage. There is a double bond O over here and a double bond O over here as well. This entire structure, this element twice oxygen and this element twice oxygen forms my benzoyl peroxide. Finally, moving on to my metallic oxides. Any metal with an oxygen is known as metallic oxides. So we have ZNO, we have FeO, we have PbO, we have MgO. All of these are my metallic oxides. So either I can use H2O2 or my benzoyl peroxide or any of the metallic oxides as catalyst. The next thing we have over here are plasticizers. These increase the plasticity of the plastic. Now, plasticity is an important property the plastics should possess, and this property is increased with the help of plasticizers. The functions of the plasticizers are, the first one is to enhance flexibility. My plastic has to be flexible in nature, and this flexibility is enhanced with the help of plasticizers. The second is to decrease the brittleness. Plastic should not be brittle. Now, brittleness means, the property of brittleness means breaking of the plastic when it falls down. For example, glass. Whenever we throw a glass or whenever we drop a glass from the top, when it reaches the bottom, it will break off. That is known as brittleness. We need to decrease this brittleness for the plastics. Point number 3 is lower softening temperature. Now, it is very important to lower the softening temperature. Plastic should not get soft at room temperature, and that is the reason why we need to lower that softening temperature. Point number 4 is alter molding and remolding temperatures. Now, it's very important that those temperatures should not be extremely high because we'll be wasting a lot of fuel, and thus we should alter the molding and remolding temperatures. The sixth thing we add into the plastics or compound into the plastics are lubricants. Now, lubricants help during molding operations, especially during low or room temperature molding. Now, what exactly are lubricants? Lubricants are certain substances which will help to decrease friction between the two sharp objects. Apart from that, it will also help in not sticking of substances. That means if I am putting my plastic into a mold, that plastic should not stick inside the mold. It should easily get demolded out. For that property, lubricants are being added to the plastics. The use of lubricants impart flawlessness and a glossy finish. So if I have a lubricant added to a plastic and when I demold the plastic which comes out from the mold will have a glossy finish and would be flawless to the complete products. The lubricants tend to disperse themselves into the outer surfaces of the finished product. Hence, during the molding, they form a layer between the article and the mold. So, if this is my mold and if I'm putting certain amount of plastic in it, now this plastic contains lubricants inside it. These lubricants are mixed inside the plastic. But as soon as this plastic starts settling down into this mold, the lubricating substances which are mixed inside the plastic will go and settle themselves in the outermost layer of the plastic. That means these lubricating substances will form a thin layer between the plastic and the mold. And that is the reason why it is very easy to demold these plastics And whenever we demold these plastics, we will see a glossy finish on the outside of that mold, on the outside of that plastic. The last thing we have is stabilizers. Stabilizers help to improve the thermal stability of the plastics. They are required at the processing stage of the plastic. Now, what is the processing stage? Whenever I am making a plastic or remaking that plastic, I am giving certain amount of energy to it or certain amount of heat to it. So whenever I am giving that energy or heat, the plastic has to take that energy and cannot implode or explode in any way. For that, we have certain thermal stabilizers given to it, which will help in making the plastic stabilized in any form. So over here in today's session, we studied about compounding of plastics. Compounding is nothing but addition of certain materials into the plastic to improve their quality. So in today's session, we studied about compounding of plastics. Compounding is nothing but addition of various substances into the plastics to improve the physical and chemical properties. We studied many types of compounding materials and compounding agents, and we also studied what all these compounding materials do to the plastic and how they enhance the properties of the plastic. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.